So, hello everybody and welcome to this initial session here, and let's see some point clouds. So the first thing, I hope you installed CloudCompare and that you downloaded the files on the link. So I prepared this folder, and the file we will need is this scan position 16 full single scan, and then a lot of things written, 2 centimeters .las. Let's try to open it by dragging it into CloudCompare, which I have already opened. So we just take the file and drag in. We'll get this message, open last file, and then, it looks all right, so we just say apply. Here comes the global shift message. Not of concern at this moment, but we just say yes. And so here we can see already 2 million points. Wow, there we have a lot of points, difficult to see, like many things in life. We can see it, but we don't really see what's going on. It's okay, we'll learn. So I'm just opening this window here on the left. You can see the loaded files, and you have some kind of folder here which you can open and close, but the point cloud itself are these other files which are indicated by a cloud. So here we have the bar line, which is saying 750. That stands for meters, as long as our coordinates are in the correct system. And we already can get a feeling that this is quite a huge file. Once we get lost, we can press this 1 by 1 button, which is global zoom, so it will cover all the point cloud again. Let's say, we are by scrolling in the mouse, you can zoom in and zoom out. And yeah, if you press the left button, you're gonna turn the point cloud. Note that you always get a different point depending on where you click. So you already see it's upside down. And with the right button, you can move in this way without rotating. So we already see something here. It's a windbreak in South Africa. And while you have many buttons on the left side of the screen, you can try different positions for the point cloud. It might help you to visualize things. But anyway, it depends if the coordinate systems are correct and so on. So, first of all, this is a single scan. And you will notice the scanning position by this hole in the middle of the scan. If we zoom in, you will notice the points, and the more you go inside, you see more and more points. There are the trees. And you see here, these fields are berry. It's a berry farm with many windbreaks in a slope and windy terrain in South Africa. Look, from the scanning position, now we are about 15 meters. So let's say, wow, this is about 15 meters windbreak. And here another session, and there are other windbreaks, and here as well. But what I want you to notice is how far the scan can capture, so can reflect the points, or measure from the emitted pulses. And if you see this picture, it looks great. We can get another tool from CloudCompare to measure distance. So all these things are points that you see. We're gonna click again in the file to make sure we selected the appropriate cloud. And now I want you to choose this tool, point picking. And finally, you see here on the right corner, upper corner, we can select 2 points and display segment information, for example, length. So this is a way to measure distance. And then you click on it. So let's select a point in the middle of the scan. I choose here. You can say no for the moment. Oh, you already get some information. X, Y, Z, RGB. There we have. But now I want to get the distance, right? So let's get one of these points far away. And boom, there we go. So basically, this was 377 meters away. And well, there are few points even further away. So just to show you the capabilities of the laser scanning, the scanner. And that's it. We can close this for now. Or you can try actually to measure other distance. Let's, for example, measure the windbreak. Oh, let's assume it was, oh, let's look like this. This beautiful windbreak here, more or less, tree top here in the other corner. 17 meters. I was not that bad. Yeah, there was, well, it's not a straight line, but anyway, we can see the trees already from a single scan position. And now you already get the feeling of how a single scan could look like. And let me show you some other things. Well, we should maybe have started with that, but once you go again in the left and select the point cloud, so you also see in my screen here, it's a yellow line and it kind of goes around all the point cloud. It's a bit difficult to visualize, but you can change the colors, and if you want to change the white in the background, and yeah, you can set your standards, like changing the properties here somewhere. Anyway, so we select the scan, the point cloud, and here you have the properties, right? Name, visibility, oh, disappeared. We can also show the name in this, well, yeah, there is the name. Great. Let's make it invisible again. Goodbye, name. And here you have colors. Look, we have many options with this point cloud. It's not just X, Y, Z information. That would be just the X, Y, Z information. So it just displays the position and gives a random color to the points. In this case, it's set to black. It could also help you to visualize things eventually, right? You can more or less see the tree trunk and so on. In this case, the RGB information was generated with a camera on the top of the scanner. And you see, for example, that the upper parts of the trees, they get bluish points. So this is because the photos will take part of the sky, and then the tree tops are very likely to get some bluish or whitish colors. And yeah, the scalar field here, once you select scalar fields in the color, it will make available all the different attributes we have in a point cloud. So all the other dimensions of the point cloud data, as we spoke about. In this case, you see here scalar fields now, and there are 8 fields. So once you click on it, you can see all the different fields. One of the most important, and when available now, because not all the scanners will get there, could be reflectance. So reflectance is a feature that could be used already for point classification. like extracting leaves or the woody parts of a point cloud. Just to give you an overview, we can also change the way things are displayed, and so that we get a better feeling of what's going on. I mean, we can also select points, but yeah, I leave that for another tutorial. So now, actually, we have seen how a single scan could look like. We go far away, and yes. Again, if we press the right button over the cloud file, we can get some information as well. So we can press here, information, and then we see there are 2,300,000 points in this cloud. It was downsampled, which means the initial points in one single scan, they were about 8 million. And I have reduced the number of points in this so that it's easier for you to visualize. And how I reduce it by removing all the points in a radius of 2 centimeters. Okay, that's all. Let's delete this file. And it just deletes inside of CloudCompare. You still have your own file. Now I want you to collect the other clouds, which are these scan position 14, 15, and 16. We can select all of them by clicking and keeping Control button pressed, and then we can drag the 3 of them together inside CloudCompare. We again get these messages. We can now press Apply All, and we can do the same here for the coordinate shift. And yes, this could take a while because you will probably need a bit more of memory, of RAM in your computer. So I hope you have at least available 4 gigabytes, the more the better. And yes, I hope you're successful also opening these files. We give it some time. We'll see in the left panel, the scan position 14 is open. Now we should get also the next. We can already put this aside, and you see, wow, this scan position. I actually snipped out points that are far away from the scanning position, and so with that we could reduce the number of points. Anyway, you are facing more than 7 million points per scanning position. This is like in the 50 meters around the position where the scanner was. But still, these point clouds, they were not downsampled, so you pretty much keep all the points. I have to say, these scans, they were co-registered in a specific software, and they are already prepared. But here you should get a feeling of how the process goes. So we have our position, in this case is the scanning position 14, and now let's click on here to make available the scanning position 15, and finally the 16. So you see, every time I add another scan, you get more coverage, you get more points, and that's how it goes with a multiple scans approach, where you go around the landscape and collect more and more scanning positions in order to really capture the 3D information of the landscape. Okay, I leave you now for playing with that, and I hope you can handle this point cloud. See you in the next tutorial. Good luck!